Hello guys, so today I was solving this problem, maximum number of operation to move ones to the end. Okay, this is today's LeetCode problem of the day. So let's see how to solve this. Okay, so the problem states that I have been given a binary string. Okay, now in a binary string we have zeros and ones only, and the goal is to move all the ones to the right of the string. Okay, now in order to do that, they have provided us this operation which states that basically in our binary string, if I have something like a 0 1 pair, okay, then I can move this one to the right of 0, okay, and move it to the right till I find a 1, okay, and place it just before this one, or if there is no one, I will just place it at the end. Okay, cool. Now the question asks us that what is the maximum number of operation I will be needing. Okay, so this thing needs to be considered maximum number of operation. If it was a minimum number of operation question, I could have easily solved this problem by considering ones from right to left. Okay, since it is asking for maximum number of operations, so I have to think of how many blocks I can get for each one. Okay, by blocks I mean like how many blockage I can have while I'm bringing one to the right. Okay, so yeah, if I take this example, let's take this test case. So it states that 1 0 0 1 1 0 1. Okay, so if I do it from right, okay, so this one is already there, this one I will bring it to the here. Okay, then this will look something like this. Okay, now I can break this one to here. Okay, so right now I'm solving from right to left. Okay, now I can bring this one to the extreme right. Okay, like to the extreme right I mean like just before this one. Okay, so 1 1 1 0 0 0 1. Okay, now finally I can take this one and move it to the right till this point. So my string will finally look like this. Okay, so doing right to left is a piece of cake, right? There is no blockage. I'm just taking all the ones from the right and like yeah, from the right and pushing them to the right of the string. Okay, so there is no blockage. But since the question asks us to maximize the number of operation, so I just have to reverse the order. Okay, I have to start solving from left to right. Okay, now what will happen if I solve the same thing from left to right? Okay, so let's take the string again, or yeah, let's draw one other here. Now if I solve from left to right, okay, first I need to uh, check first I need to move this one. Okay, so for this one I can only bring this one till here. Okay, so because this one is blocking this one's final position. Okay, if I see the final position for this one is this place. Okay, so this guy is already blocking this one's place. Okay, so I am getting a blockage, which means it will contribute to the final number of operation. Okay, so let's go with this. So here I'm taking one operation, so I'm bringing this one to here, 0 0 1 1 1 0 1. Okay, now I have to search. Okay, where I can find the 1 0 pair. So I'm looking at this. Okay, so I will bring this one to the right. Okay, till this position. So this will look like 0 0 1 1. Okay, 0 1 1. Okay, so this, since this one was blocking this one from going to the extreme right, so yeah, I will be placing this one here. Okay, now again I will check, do I have a 1 0 pair? Yes, I have. So I will bring this one to here. So third operation, 1 0 1 1 1, and finally I will bring this one to here. Okay, 0 0 0 1 1 1 1. Okay, cool. Now if I look at this, okay, I think both of these cases are producing the same result. Let's check here. I took 1 2. Oh yeah, yeah, so yeah, from going from right to left I took only 3 operations. Okay, but if I go from left to right, okay, I'm getting 4 operations. Okay, So yeah, so the question, so in order to solve this question, I just need to do it from left to right, okay, and that will increase the number of blockage for everyone's, okay, and yeah, and then I just need to simulate whatever I drew here, okay. Cool. So how to solve this? So here in the simulation, if we look, so for every 1 0 pair that I'm seeing, okay, it means that it will act as a blockage for me, okay, not as a blockage. You can think like I need to move this, okay, which means one once like one one's final position is not set, okay. Like if I look at this, okay, this guy's final position was not set. I can easily say that from this 1 0 pair, okay. Then yeah, then because of this, whatever ones are present to the left of this guy, okay, though their position is also not set yet, okay, I need to perform this operation in order to set their, like, bring those one to their final positions, right? So yeah, wherever I'm getting this 1 0 pairs, that means whatever ones are to the left, so including this one, are left of this pair, will need 1 1 operations, okay. So if I see here, let's take this, okay, 1 0, let's darken it up, okay, 0 1 1 0 1, okay. So let's go from left to right, okay. I'm seeing this guy, okay. So right now I cannot find anyone, so I can find only 1 1, which is this one itself, okay. So my answer will go up to 1, okay. Then let's go here, okay. Here I'm not finding any 1 0, okay. Here I'm not finding any 1 0. Here I'm not finding any 1 0, okay. And let's keep a running count of our ones, okay. So 1, still here is 1, still here 1, still here 1. When I reach this position, still I'm not getting a 1 0 pair, but I'm getting 2 ones, okay. Now in this position, okay, I'm getting 3 ones and I'm getting a 1 0 guy, okay, which means whatever ones are present to the left of it, okay, their position needs, like, this operation needs to be performed over these ones, okay. So I can see I have 3 ones, okay. I can simply add this to my answer, okay. So I'll be needing till 4 operations. So let's erase this guy, okay. So yeah, 3 operation. Then I will bring my pointer to here, so it says 0. Am I getting a 0 1 pair? Nope. Cool. And finally for this one, like, this is already set, and yeah, I am not getting any 1 0 pair. Cool. So whenever I'm getting 1 0, okay, I simply need to move, uh, I simply need to, like, calculate how many ones I have already covered till I reach this position, okay. Then I need to add that up in my answer, and then I will just keep on moving. Cool. So let's code it up. Let's find let's first store the length of the string, size, then int ans 0, and to capture, like, how many ones I have covered when I'm traversing the string from left to right, I will keep a counter once 0. Then let's iterate over the loop. So 0 left to right, let's bring this guy here, let's increase here, okay, I plus plus, okay. And finally I will be returning ans. Cool. Now I will check, I will increment once if my current character is 1, okay. Now if my current character is a 0, okay, what I will do is, it means I need to add up all the ones that I have covered. Okay, so I can do ones plus equal to all the ones. Okay, then I can update my I, okay, uh, to the right. Okay, so that I can avoid some unnecessary iterations. Okay, so I can do j equal to I. Now while j is less than n, and s of j is still 0. Okay, I'll simply keep on incrementing j. Okay, and finally this will be like either over or it will be set to 1. Okay, so I can set I equal to j minus 1 here, and later on it will get incremented. Cool, so this should work. Okay, so this is just to like prevent unnecessary iterations. Okay, so that the overall algorithm, so you can do it without while loop, but I think it is a little bit intuitive. Okay, I'm just skipping over all the intermediate zeros. So for example, I have something like this 1 0 0 0 0 0 0 1, something like this. Okay, I got it here. Okay, then I can bring this pointer directly to here. Okay, this is what I'm doing. Okay, so yeah, because I know this guy is 0, so let's uh, skip all the zeros to the right and let's reach at a 1. Okay, so yeah, should be done, and let's run this. Okay, it's running, let's save it. Okay, it's happening. Cool, not in the best position, but yeah, still 6 millisecond is good. But yeah, don't trust this. Let's do the same thing in Go. Okay, the code will be pretty identical, so let's initialize our length of the string, our ones with 0 0 and 0. Okay, in Go you don't need the semicolon, it's just a good practice to have it, but yeah, you actually don't need it. And let's calculate, let's start our iteration from I 0, I less than n, I plus plus. Now if I have to use rune of s of I is equal to rune of 1. Okay, I need to increment ones. Okay, otherwise if it's a 0, okay, I can increment my answer directly to whatever ones I have covered till now. Okay, and I will skip past all the afterwards 0. Okay, so I'll say if I'll create a j equal to I. Now for j not is less than n, and rune of s of j equal to rune of 0. I will simply increment j. Okay, and finally I will set I equal to j minus 1. Okay, and I will return ans. Should work. Didn't work because I didn't incremented by ones. Cool. It's taking a long time. Okay, something is not working. Rune of s of I equal to this. Let's see. Once is here, once is initialized to 0. I have my ans equal to ones, j is I, j is this. So my ans is not at all incrementing. So we are not coming here, or this is not working. Interesting. Mm-hmm. Am I reaching here? Yep. Will it complain? Okay, it doesn't complain. So we never executed this line because s of I is haha. Cool. This should work. I haven't initialized n to len of s, so yeah, cool. Cool. Then finally, let's do it for Rust. So let n be the s of len. Now in Rust, you cannot compare characters directly because they are UTF-8 encoded. Like similar thing with Go, I have to use rune. Okay, but yeah, in Rust, I do not have rune like functionalities. What I can do is I can convert the whole string into bytes. Okay, so I can say let bytes equal to s as bytes. Okay, then I will create my ans and uh, uh, one counter. Okay, mut once I will say 0 with 0. Okay, then finally I need to return ans, and before that I will be writing this for loop. It's better to write a while loop here. Okay, because in for loop I cannot have those like it doesn't support C++ like for loops, so yeah, it's better to use a while loop here. So yeah, and not Golang I equal to 0 as use size while I is less than n. Okay, I plus plus, and yeah, if uh, bytes of I is equal to the byte representation for 1. Okay, I will increment once. This is not allowed. I will do this. Else, I will increment ans with ones, and I will do that skip operation. So I will create j. Let mut j is equal to I. Now while j is less than n, as well as bytes of j is equal to the byte representation for 0, I will increment j. Okay, then finally I will set I equal to j minus 1, and it will get incremented again. Cool, should work, fingers crossed. Rustition, yeah, it doesn't allowed. Why it doesn't allowed? I will again get this. Let's wait. Peace. Let's peace out our mind. Now let's do it again. Cannot assign twice. I have to create it mutable. Yes. This is mutable. This is mutable. This is, yeah. Taking time should work. Yeah, it worked. Cool. Let's submit. Cool. So all done. C++, Golang, Rust, all three solutions. And I think the time complexity will be what here we are skipping the ones. So basically we are touching each element once only. So it's a big of n operation n time complexity, and we are not using any extra space. So yeah, constant space time complexity. Cool. So I hope you guys are able to grasp the concept behind this question, and I hope I have written a good code. So yeah, please do like and subscribe if you find this video helpful. I will be bringing more of this kind of a content. So yeah, just stay tuned. Thanks. Bye bye.